For today's lesson, we're going to factor polynomials using the greatest common factor. Essentially, we are going to undo the multiplication that you did in your lesson preview. We're going to take our new binomial and take out the greatest common factor. What do 50 and 120 share? So the greatest number that goes into both is a 10, because we know 10 is a factor of 50. We know 10 is a factor of 120. So the GCF, or the greatest common factor, is what factor they have in common. So the GCF for question C is 10. Now, if we take a look at the greatest common factor for our next three terms, think about the number they all have in common. They all have a common 6. Think about the x's. We have x times x. Here's an x and an x. So how many do they have in common? You can see that they have one x in common. What about the y's? 1, 2, 3, 1, 2, 3, 4, and 1, 2, 3. Let's see here. So they have 3 y's in common. So the GCF for these three terms is going to be 6xy to the third. So we're going to look at example 1. Find the greatest common factor for each of the following. Start by thinking about 10 and 25. So we have 10x to the third, 25x squared. The number that they can divide into both is a 5. Now what do we have left over? 2x to the third and a 5x squared. Now how many x's do they have in common? They both have an x squared in common. So if I were to take the x squared out, what we see is that the GCF is 5x squared. Now let's look at number 2. Notice they have a negative 45 and a negative 18. What number divides into both negative 45 and negative 18? So if you're looking at it and you say negative 3, you are almost right. Let's try it. Pull in the negative 3. That gives you a 15xy squared and a positive 6x squared y. But notice 15 and 6, they have another 3. So let's divide that one out. That gives us 5xy squared and x squared y. All right, so now what variables do they have in common? Do you notice that they both have an x and a y? So let's write x, y. And let's see, what is going to be remaining? We're going to have a 5y and another x. So the GCF is everything that they have in common. In this case, negative 3 times 3 is negative 9xy. So the GCF is negative 9xy. So looking at question number 1, give the numbers 12 and 60 a try, find out their GCF, and then work on questions 2 through 4. All right, now we're going to factor each polynomial. And in order to factor the polynomials, first you want to check to see what numbers they share. So the first terms, we're looking at 8, 16, and 4. So I see a 4. Then check out your x's. Notice that each one of these monomials has one x. So we're going to write the GCF in front of the factored form. Now, division. 4 goes into 8 twice. We took away one of the x's, so we're left with x squared. 4 goes into 16 4 times, and we have an x remaining. The 4x was taken out, but we still have a minus. We need a placeholder. That placeholder is 1, because 4 goes into 4 1 time. So we have our GCF, and I'm going to lovingly call this the leftovers. So we've changed our form of the equation into an equivalent form through factoring. Check out question number 4. Notice they have a negative in common. Factor the negative out. But what else do they have in common? 14 and 12 are both divisible by 2. And x squared are divisible by x. So now that is your GCF. What are the leftovers? 2 goes into negative 14 7 times. That x is gone. Plus, because remember we took away that negative, 6, we took away one of the x's and we get a 6x. So this again is our leftover. Now the next part is we can check our answers. Use that distributive property if you want to check your answer. We get negative 14x plus 12x squared. We're back where we started. So the factored form is going to be negative 2 times the quantity 7 plus 6x. All right, we have another trinomial. Notice that we can factor out a negative 2. Because that lead coefficient is negative, I'm going to factor the negative out. If it were positive, I'd leave it alone. Each one of these terms has an x. Each one of these terms has a y. So now we found our GCF. What remains? 3x. The 2 is gone, but we took away a negative. So that changes its sign. And we have a y. Negative's gone. Here's your plus 2. And now we have our monomial GCF multiplied by a trinomial for the leftovers. Give the next set of questions a try. So this is our first type of factoring. And factoring is a way to rewrite your polynomial expressions. The first thing we always look for is a GCF. We draw the parentheses. If you need to write the word leftover factors to help you remember what you're doing, then please do. And you can always check your answer. So for number 6, this is a type of word problem you might see. Samantha's making beaded necklaces with 54 glass beads and 18 clay beads. She wants the necklace to have the same number of beads, but each necklace will have only one type of bead. If she puts the greatest possible number of beads on each necklace, how many necklaces can she make? Make certain that you are aware of the question. So we have 54 glass beads and we have 18 clay beads. If we look for the GCF to help us out, 18 is 3 times 18 is 54. And 18 is 1 times 18. So we could make 4 necklaces that have 18 beads each. And we get that through the process of finding a GCF. All right, give these practice and I will set up a few answers for you.